All right, number 2, we're asked to graph this function. It's got an absolute value in it, so we're going to have to break it down into cases. So remember the definition of absolute value. The absolute value of something is either the opposite of that thing, if what we're plugging in is less than 0, or it's just the thing itself, if what we're plugging in is bigger than or equal to 0. So if I look at the absolute value of x minus 2, it's either the opposite of x minus 2, if the x minus 2 is less than 0, or it's x minus 2 itself, if the x minus 2 is greater than or equal to 0. Simplifying this, it's either minus x plus 2 if, now let's look at this condition, solve this inequality here. If the x is less than 2, or it's plain old x minus 2 if, solve this inequality, x is bigger than or equal to 2. So I'm going to substitute these expressions in here for the absolute value of x minus 2 to get my new function f of x. So f of x is x times the absolute value of x minus 2, but the absolute value of x minus 2 is going to be given by this formula for x less than 2. Or it's going to be x times this formula for x bigger than or equal to 2. And I can simplify this to minus x squared plus 2x for x less than 2, and x squared minus 2x for x bigger than or equal to 2. Each of these things are parabolas. So what I have to do is graph each of these parabolas for each of these parts of the real number line. Alright, so we're going to graph the equation y equals f of x. So if x is less than 2, I'm going to be graphing this equation. If x is bigger than or equal to 2, I'm going to be graphing that equation. Well, this is going to give me a parabola, so let's look where the vertex is. I can get the x-coordinate of the vertex using the vertex formula, minus b over 2a. Minus b in this case is negative 2 over 2a is negative 2. I get x equals 1. Since x equals 1 satisfies this inequality, 1 is less than 2, I know that I'm going to see the vertex on this part of the graph. To get the y value of the vertex, I plug x equals 1 into this formula. Sure enough, I get out y is also equal to 1. So we'll put our graph over here. And we've got the point 1, 1. And that's the vertex of this parabola. Now, I'm going to have this parabola up to but not including x equals 2. So as before, if I plug 2 into this, I'm going to find out where the hole in the graph is going to be. I plug 2 into that, I get negative 4 plus 4, which is 0. So that means that over here, at least momentarily, I have a hole in the graph at 2, 0. Alright, now because of the symmetry of the parabola, you notice I went 1 unit away from the vertex. I'm down on the x-axis. If I go 1 unit to the left, I should also be down on the x-axis. And now I can graph this parabola. It comes up and heads down and it stops there. Okay, so that's the first half of this piecewise function. The second half, y equals x squared minus 2x, this is good for x is bigger than or equal to 2. If I attempt to find the vertex of this parabola using the vertex formula, here negative b is 2 and a is 1 again, I get x equals 1. But x equals 1 doesn't fall in, doesn't satisfy that condition. So on this parabola, I'm not going to see its vertex. I know the vertex is at 1. I know it opens upward. So I'm going to have a parabola that looks like this, but I'm not going to see the vertex there. So what I'll do is I'll plug in x equals 2, see what point that's at. And sure enough, I get out y equals 0. So as we've seen before with these absolute value functions, the hole that we get gets filled in. And then I need another point on this parabola, so I'll choose, say, x equals 3, y equals 3 squared, minus 2 times 3, and that gives me 9 minus 6, which is 3. That's up there. And so it's going to be heading upward like, oops, I mean not straight up like that, but it is pretty steep incline here. So it goes like that. Okay? So we've got this followed by that. That'll do it for number 2. That'll do it for checkpoint quiz 2.3.